Okay, we return to day 41 for the second part, part B. This page, interesting that we have left to do, has nothing to do with the Pythagorean relationship at all. It the it instead is word problems and practice problems dealing with fractions and decimals. I think it actually comes from another part of the study guide and somehow got over here by mistake. When I went to check one of the answers, it's not even included in the answer guide. So you can do this page as practice for decimals and fractions, and I guess it's a good review. We already covered this in earlier lessons, but if you want to do it as a review, you may. I'll go through the problems. Okay, number one, a word problem. During a 25% off sale, store clerks find the amount of discounts by multiplying the regular price by 0.25, because 25%, remember, is the decimal 0.25, 25 hundredths. What is the discount on an item with a regular price of $80? So it's 25% off. So you want 25% of the regular price of $80. When you hear that word of, it's a clue that it's multiplying. So you want 25%, but of course we must use the decimal, 0.25 times 80. And if you put that in your calculator, you get 20. Now, 0.25 is also, you might not realize it's the fraction 1/4, and 1/4 of 80 means 80 divided by 4. 1/4 of is 80 divided by 4, because 80 times 1/4 would end up with an 80 divided by 4. Anyway, it's 20. Okay, $20. Now, when I look at these numbers, I see some small numbers and I see some big numbers, and I wonder, wait a second, I better check. What are they asking for? They're asking for the discount. They're not asking for the new price. The new price would be 60 because you would subtract 20 from the 80. But they're asking for the discount, so the answer is 20. B. Again, you should be trying these problems before I do them. I'll just warn you, don't do number 6. Number 6, because there's a mistake in the problem. Anyway, we'll get to that eventually. Number 2, at Linton Products, 3/10 of the workers are in the company's rideshare program. If there are 480 workers, which of the following expressions could be used to find the number of riders in the rideshare program? So it's 3/10 of 480 are in the program. That means 3/10 times 480. 3/10 of the 480. Okay. Now, we don't have to figure out the answer. We have to find out which expression is correct. Notice they're not using fractions. They're using decimals. So you have to change this to a decimal. Now, you could put it in your calculator, 10 divided by 3. But if you know decimals, you know that 3/10 in a decimal, this is the tenths. That's the hundredths. Tenths. So 3/10 is just 0.3. 0.3 times 480 should give you 3/10 of 480. And there's 3/10 times 480, not divided by. If you use this one and you divided, your answer would come up like 1,200. Well, you can't have 1,200 or 1,300 workers that are in the rideshare program when there's only 480 altogether. So the answer has to be smaller than 480. So it would be 0.3 times 480. Where do they get this 0.7 from? Well, 0.7 are the workers who are not in the program. You would take 1 minus 3/10, you get 7/10. This would give you how many workers. This one on top would give you how many workers are not in the program. We want workers in the program, 3/10 times 480. Number 3, a steel rod 3 meters in length is cut into 8 equal pieces. What is the length in meters of each piece? Well, the big rod is 3. This is 3, and you want to cut it into 8 sections. So you're going to get in half, then those in half, and then those in half. They're going to be little pieces, right? Little pieces. In fact, if they were cut into 3 pieces, they would be 1 meter in length. But you're cutting them into 8 pieces, so it's got to be smaller than 1. So this one's out. It's got to be smaller. How could it be 2 meters long if there's 8 pieces? They got to be pretty small. So any of these answers could be correct. If you're taking 3 meters and cutting it into 8, you're dividing it into 8. Guess what? 3 divided into 8 pieces. 3 divided by 8. If you put it upside down, 8 divided by 3, you're going to get that answer. Actually, that's 7 divided by 3. I don't know why they have 7 divided by 3. Anyway, you want 3 divided by 8. And if you put that in your calculator, it comes up to this one, 0.375. Okay. Number 4. Marion is using a calculator to find out how many hours she has spent on a certain job. She divides and her display reads 4.66666666. Assuming her calculations are correct, how many hours did she spend on the job? Well, we know she spent 4. These have 4. This has 46. So forget. How could she spend 46 hours when she only spent 4? So get rid of D. It's got to be one of these. Okay, we want 0.66666666. Now, you really should know what fraction that is because it's a relatively common fraction. And I know I've gone over it in class. But if you don't know, what do? Well, this is one of those ones. It's easier to change a fraction into a decimal than a decimal into a fraction. So what you do is you go to the answers and you say, which one of these gives you 0.66? And we're only interested in the fraction part. So if you put 1 and divide it by 6 in your calculator, I don't know what you get. Oh, 141414, something like that? No, I don't think so. I forget what you get. Oh, 171717, something like that. So you try 2 divided by 3. If you put 2 divided by 3 in your calculator, you get 0.6666. It goes on and on until the last one, they round up to 7. Anyway, that would be a good answer. Actually, this would not be a good answer because they would always round the last one to 7. They wouldn't leave it like that. Anyway, 4 2/3 is the correct answer. This is one of those that it benefits that they have multiple choice because you could look at your answers and find out which one does that. You can check your answers till you come up with 0.666. Anyway, as I was saying, you should know some important fractions, like 1/4 is 0.25, 2/4, 1/2 is 0.5, 3/4 is 75, like 75 cents. The thirds, 1/3 is 0.333333. They put a line to show that it repeats. And 2/3 is 0.66666 with the 6's repeating. Those are good ones to know. Okay, moving on. Number 5, a gourmet candy company charges the following prices per pound: jelly beans, peanut brittle, almond toffee. How much would a customer pay for 1.5 pounds of peanut brittle? So you have to find peanut brittle, $12 a pound, and you want 1.5 pounds. So it's more than 12. 1.5 times 12. You could put 12.00, it doesn't matter. That would give you the cents too. Anyway, 1.5 times 12 comes out to 18. I remember when we did this with another class, the way one of the students solved it, he just said 1.5. 0.5 is 1/2. So he's getting 1.5 pounds of peanut brittle. 1 pound is 12. A half a pound would be 6. 12 and 6, 18. That's how he solved it. Any way you can solve something, the better, because it shows that you're understanding and finding the answer on your own. Okay. At 1 p.m., the amount of rain in a rain gauge is 1.25 inches. What fraction of an inch of rain fell between 1 p.m. and 3 p.m.? How would I know? It doesn't say that it rained. It doesn't say that how many was there at 3 o'clock. Something's wrong with this problem. They left out information. I'm guessing whoever typed this over left out a whole line here that it said at 1 p.m. the amount of rain in a rain gauge was 1 inch. At 3 p.m., the amount of rain in the rain gauge is 1.125 inches. What fraction of an inch fell between 1 and 3? I think you were supposed to take 1.125 and subtract 1. Oops, sorry, I didn't write that right. 125 and subtract 1. You would get 0.125. And then you just had to find which answer is 0.125 by dividing them. 7 divided by 8? No. 3 divided by 4 is 0.75. 7 divided by 16? I don't even know what that is. 1 divided by 8? 0.125. I assume that was what they asked. But they might have asked something different. They might have said at 1 p.m. the rain gauge was 0.825 or something like that. I don't know what's missing there. And when I went to check the answers, it doesn't have the answers for any of this page. So this one, I'm guessing that it was 1 inch at 1 p.m., but who knows. Okay, number 7. Joseph has been working on his batting technique for this baseball season. His batting average increased from 0.185 to 0.245. By how much did Joseph's batting average improve expressed as a fraction? Okay, it went from 0.185 to 0.245. How do you find out how much it went up? You take away, starting with the big one, 0.245. I never put the 0 in the front. A lot of people always say there's a 0 in the front. You don't need the 0. 0.185. And you subtract. You could put this in your calculator, but it's pretty easy because the digits are almost the same. This one would be 6, you borrow, and this one would become 0. So 0.060 or 0.06. Now, here's your answers. Which one's 0.06? You could put it in your calculator and divide. But if you understand what decimals are, this is the tenths place, this is the hundredths place. So 0.06 is the same as 6 hundredths. But if you put these in your calculator, this one, 6 hundredths, would come out 0.06. The 0 on this side, by the way, isn't important. That you can just drop off, 0.06. 6 thousandths is this, 0.006. That's 6 thousandths. That's not the same as this. This one's 0.06, 6 hundredths. Okay, moving on. Okay, write each decimal. Write each as a decimal. Use repeating decimals when necessary. Okay, very easy with a calculator. All you do is put it in your calculator. Now, some of these you should know without even a calculator. What's 1/4? Think of money. This is also called 1/4, 0.25. This one you have to put the 2, right? 3/5. You might know your fifths. 1/5 is 20, 0.2. So 2/5 is 0.4, 3/5 is 0.6, 2.468. That's your fifths. Okay. Again, put it in your calculator. 3 divided by 5. You don't need the 2. 3 divided by 5, 0.6. 3/8. Put them in your calculator. I can't see that correctly. Is that 5/8? Okay. You can do all these in your calculator. 3/5 again would be 0.6. 7 200ths. Well, we want hundredths. Hundredths would be half of that. You take half. Half of 7 is 3.5. And hundredths is decimal 0.03. That's 3 hundredths. 3.5 would be this. But you can just put in your calculator and get the answer. This one you would definitely want to put, well, you didn't know, that's 25ths. So this one you can multiply the top and the bottom by 4 and get hundredths. Is that an 8? That would be 32 hundredths. 0.32. Okay. Anyway, calculator for all of these. This one you definitely want to use a calculator. It's got, is that 13ths? Calculator. Anyway, you can do a calculator, find those answers real easy. What's harder is going from a fraction to a decimal. If you have to go from a decimal to a fraction. If you have to go from a decimal to a fraction, and you're not sure how to do it. So that's 2/10. Let's try this one. 2/10 is the same as 2/10. And you have to reduce. That's the problem. 2 goes into 2, 1. 2 goes into 10, 5. It's 1/5. That would be your answer for number 20. How would you do it if you if it's a hard one, like maybe you don't want to reduce 0.76, this one here, 0.76, well, you would end up with 76 hundredths. Then you might want to divide by 2, you might want to divide by 4, you might even, well, you can't divide by 8 because 8 doesn't go into 100, does it? You might want to divide by 2 or 4, you don't know. What do you do? Well, if you get a hard one that you don't know how to solve it, like for instance this one, what does this mean? This means 0.151515 all the way. How are you going to solve that? Well, what you can always do is, since it's multiple choice, you look at your answers and you try them. So for instance, on this one, which is really hard, A, let's say you have 1/15, B, 3/13, C, 15/99, D, 17/83. What you do is you just plug these into your calculator. 1/15, what does it give you? 3/15, or 3, whatever that is, 13ths, what does it give you? You put this one in your calculator, it comes out 0.151515, and you say, oh, that's the right one, see? So you work backwards. You take the answers and you convert them to decimals. You take the fraction, convert it to decimals, easy, and then you find the right answer. How do they really want you to solve this? Well, this is what they want you to do. Watch this. X equals 0.151515. So I'm going to say 100x. I'm going to multiply x by 100. That's equal to 15.1515, because you just move the decimal point over. And you got all these 1/5s. And then you subtract. 5. All these are going to become 0. 0, 0, 0, 0, 0, 0, except for the last one. 15.00. And you also subtract this side. 100x minus 1x is 99x. Equals 15. 99x equals 15. So x equals 1599. So you divide both sides by 99, and that's x. 1599s. Okay, are you expected to remember to? No, nobody remembers how to do that. I barely remember how to do that. So don't even worry about it. They won't have that on the test. And again, if they do, just go and work backwards. Convert your fractions until you find the right answer, the right decimal. Okay, so you can work on these if you like. See if you can figure out that. This one would be 0.33333333. Remember what that is? That's 1/3. That one's 1/3. Anyway, oh, actually, you can't work on these on your own because you don't have multiple choice. And the way I taught you to do this, look at your multiple choice. So you can try reducing these repeating ones. Of course, you can try it the way I tried it. This one you would say x is 0.0999. 100x is 9.0999, and then you would subtract. This one only has 1, so you would do x equals 0.7 repeated, and you would only do 10x because you only have to move it one space. If there's 2 digits like this, you have to move it 2 spaces. 10x is equal to 7.777, and when you subtract, you get 7 is equal to 9x, and so x is equal to 7/9. Okay? I wouldn't worry too much about this exercise, though, because like I said, if you have multiple choice, convert your answers, your fractions, into decimals to find the right answer. Okay? So this page was thrown in there, but I think it's in the wrong place. It doesn't belong in this lesson on Pythagorean Theorem, where you do a squared plus b squared equals c squared. But it's a good review for fractions and decimals.